Okay, so let's look at this example where we were asked to look at the curve that is, oops, so we've got the curve. Okay, let's look at this example where we try to figure out something about the curve y times y squared minus 1 times y minus 2 equals x times x minus 1 times x minus 2. So here's a plot of the graph from Desmos, and we've been asked to try to figure out what's going on in terms of horizontal tangents and vertical tangents. So if we're thinking horizontal tangents, we're going to see one here, one there, one there, one there, one there, one there, one there. So that's, oops, and one more there. So there's 8 horizontal tangents that we're expecting to find, and in terms of vertical tangents, we look at 1, 2, 3. But let's see if we can try to find these locations a little more precisely. So if we come in and we do our implicit differentiation, and we're going to need some product rule as we go along here, so let's just work that out, and you're going to get dy dx times y squared minus 1 times y minus 2 plus y times 2y dy dx times y minus 2 plus y times y squared minus 1 times dy dx equals x minus 1 plus x minus 2 plus x times x minus 2 plus x times x minus 1. Okay, and a little bit of solving gets us down to dy dx then is equal to, let's see here, x minus 1 times x minus 2 plus x times x minus 2 plus x times x minus 1 all over y squared minus 1 times y minus 2 plus 2y squared y minus 2 plus y times y squared minus 1. So what's going on here? If this equals 0, we have a horizontal tangent. And if this denominator equals 0, then dy dx is undefined, and so we get a vertical tangent. So this feels like, okay, we need to come down and do some solving. So let's take a look at the vertical tangent case. So first, so we know that we need the denominator to be 0, so that was y squared minus 1 times y minus 2 plus 2y squared times y minus 2 plus y times y squared minus 1 equals 0. And use your favorite way to find roots of polynomials, so Wolfram Alpha, or graph it on your graphing calculator and use a root finder, and we find that we get y equals a half. Y is 1 half times 1 minus the square root of 5, and y is 1 half times 1 plus the square root of 5. And so then you say, well, but what do I do with that? That doesn't give me x and y coordinates. If we think back to our graph here, we're going after vertical tangents. Well, we can see sort of some different things going on here. We've got a vertical tangent here, we've got a vertical tangent here, we've got a vertical tangent there. So there's our y is a half, there's our y is a half of 1 plus root 5, there's our y is a half of 1 minus root 5 lurking down there. But what are the x values that go with those things? Well, this is where the equation of the curve comes in. And so what we really need to do is sub in for y in curve equation. And so then we're looking at needing to solve something like, if I just, for example, put in a half for y, we've got a half times 1/2 squared minus 1 times 1/2 minus 2 equals x times x minus 1 times x minus 2. Solve for x using, again, graphing calculator or whatever, and we'll get that x is approximately 2.21028. And let's bring the graph back up. So that was y is a half. Y is a half right here. Y is a half. And then x is, that's about 2 1/4, 2.21028. And you repeat that process, just instead of putting in a half here for y, put in 1/2 times 1 minus root 5, and then put in 1/2 times 1 minus 1 plus root 5. And you'll find the other vertical tangent points are, let's see, so we get minus 3.2, oops, that's not right. Minus 0.325 goes with 1/2 of 1 minus root 5, and we get minus 0.325 again for 1/2 of 1 plus root 5. And that shouldn't be surprising that we're seeing two things here with the same x coordinate. That works out. Okay. So now let's think about the horizontal tangent. Okay, so to deal with the horizontal tangent situation, we start by figuring out when x minus 1 times x minus 2 is x times x minus 2 plus x times x minus 1 is 0. Which really is just saying 3x squared minus 6x plus 2 equals 0. So that is x equals 1 plus or minus 1 over root 3. So now we're going to put back into the equation of the curve. And so we wind up needing, for x equals 1 plus 1 over root 3, we're looking at y times y squared minus 1 times y minus 2 equals minus 2 over 3 root 3, and that gets us that y is minus 0.182, 1.182 minus 0.926, and 1.926 approximately. And when we put in x equals 1 minus 1 over root 3, we've got y times y squared minus 1 times y minus 2 is 2 over 3 root 3. And solving that, we get that y is approximately 1.229, 0.771, minus 1.058, and 2.058. And so let's quickly bring our Desmos graph back up here, and we see 1, 2, 3, 4 places here around 1 minus 1 over root 3, and here around 1 plus 1 over root 3. We've got 1, 2, 3, 4. Let's just bring in some vertical lines here. X equals 1 plus 1 over root 3. Yeah, okay, that's there. And then x equals 1 minus 1 over square root of 3 is that one there. So we do get 4 different things. So they really did line up. We might have suspected that, but until we actually went to figured that out algebraically, we weren't so sure about whether that was really what was happening there. Okay, so that's how we find where the tangent line to that graph is vertical and horizontal.